Assalamu alaikum, my dear students. Let's have topic of trigonometry. We will learn about trigonometric ratios and how we can calculate angles and sides with the help of trigonometric ratios. So first of all, look at this concept. What are trigonometric ratios? And then we will move in an area where we will get help from these trigonometric ratios to deal with the sides and angles of right angle triangle. Here we have this topic, and if you look at here, this is a right angle triangle where right angle is given, that is 90 degree, that's angle C. This whole explanation about the relation in the form of a ratio of these sides is actually depending on this 90 degree angle and followed by the angle which actually consider here as angle A. There might be angle B as well, but first of all I'm going to develop the concept of from ratio towards the name of their trigonometric functions, and then we will move further explanation. So in this triangle the condition is if there is right angle, like here I have mentioned that if angle C is 90 degree in the triangle ABC, then what will happen? I have labeled angle E here first, and according to this angle I'm going to develop the ratios of the sides of this right angle triangle. Then we will label their names according to the respective ratio. Like if you look at the first one, if this is 90 degree angle and then the ratio of BC over AB, from this right angle triangle, this BC over this AB, this ratio is called opposite over hypotenuse. Why we say opposite? Because this is in the opposite direction of this angle mentioned, angle A. This is in opposite direction. You can see here, this is opposite. So in any right angle triangle, the side that will be opposite to the angle which is under discussion, that will be called opposite. And the longest side in the triangle that is opposite to the right angle will be called all the time hypotenuse. And the third side that will be considered all the time adjacent. But it depends on this angle. Here I have mentioned angle A. Now these names, hypotenuse, this is opposite, adjacent is according to this angle. But if this angle changed up to here, if you consider angle B, these two legs of this right angle triangle will have different names. For example, if this is angle, suppose, then definitely this will be opposite and this will be considered as the adjacent. But here we are supposed to consider or name the sides according to this angle A. So the ratio of BC over AB is equal to opposite over hypotenuse, and this is called sine. This ratio that is opposite over hypotenuse, my dear students, is called sine, and a sine of angle that we have mentioned here. And in short form we can write this sine of A equals opposite over hypotenuse, or opposite over hypotenuse is equal to sine of A. We will pronunciate this word, full word sine, as it is written here. Do not pronunciate it like the shorter form, but this is all the time full word sine. This is sine of A always equals to opposite over hypotenuse. And the second ratio, let's see, this is AC over AB. Here AC is the adjacent here, as I have mentioned earlier, divided by this is hypotenuse, this is AB. So AC over AB, that is adjacent over hypotenuse. This ratio was named with adjacent over hypotenuse is called cosine. It's a cosine, but this is cosine, balance word. Cosine of angle A, and in short form we can write cosine of A equal adjacent over hypotenuse. And the third ratio, BC over AC, look at here, this is BC here, that we named here opposite, and AC that is named before is adjacent. BC over AC, this ratio which is opposite over adjacent, is called tangent. This is tangent of angle A, and it is short form TAN. We will write only up to 2AN, but we will pronunciate all the time as a full word. Tangent of A equals opposite over adjacent. These are three trigonometric ratios, my dear students. ये हमारे पास तीन ratios हैं that we have written from this right angle triangle, और इन तीनों को हमने नाम दिए according to their descriptions. And here is this side BC in this right angle triangle is opposite when angle A is considered to be under focus, and this is hypotenuse, the longest side of this triangle. So opposite over hypotenuse will be all the time trigonometric ratio sine, and the second ratio, this is adjacent over hypotenuse, will be all the time cosine, and this is opposite of this is adjacent over hypotenuse, and the third ratio is BC over AC, that's opposite over adjacent, will be all the time tangent of the angle here, that's the marked angle A. So these three ratios, my dear students, with the name sine, cosine and tangent are called, these three ratios, sine, cosine and tangent, are called trigonometric ratios. I hope you understand from where we have driven these concepts and reached up to their label names sine, cosine, tangent, which are called trigonometric ratios. And now we will get some practice with the help of some examples where we will have some labeling on the sides of right angle triangle, and we will get practice about the sine, cosine and tangents. Let's see, look at the example. This is example number. Alright, my dear students, look at this example number 1. We are going to get practice how we will write the ratio of sine, cosine and tangent in the form of sides, and how will we use it in questions. So before entering into question or use of trigonometric ratios, let's have some practice. My dear students, we have given triangle ABC, and I mentioned that angle C is right angle. Look at this triangle. We have labeled three sides with the alphabets. This side is labeled with alphabet A, this is labeled with B, and this hypotenuse is labeled with C. We will write the ratio in the form of sides in front of these three trigonometric ratios that we have learned. That trigonometric ratios are sine, cosine and tangent. Let's write the ratio of these trigonometric ratios, as we know that sine is equals to opposite over hypotenuse. We need to learn first, then we will practice it like we're going to practice here. So my dear student, you need to learn first what sine is equal to, that is opposite over hypotenuse. Now after learning, now we are going to get practice so that we have comparatively stronger concept. So sine is equal to opposite over hypotenuse. Look at the triangle. Here I have considered angle A. Here is angle A. So according to this angle, which side is the opposite? As I mentioned earlier, look at here. Every time the side that will be opposite to the angle that will be considered opposite. Here A is opposite. So opposite over, that's hypotenuse, and hypotenuse here is represented by C. This will be in the form of ratio. A over C is the sine ratio here in this right angle triangle when we consider angle A. Now look at cosine. We know cosine is equal to adjacent over hypotenuse. And here is, if this is opposite, this is hypotenuse, and the third side with which this angle A is actually made, so that is called adjacent. So B is adjacent here. We know cosine is equal to adjacent over hypotenuse. This is adjacent and this is hypotenuse. Cosine will be equal to B over C. Adjacent over hypotenuse. And then look at tangent. We have learned that tangent is equal to opposite over adjacent. If opposite of adjacent is here, we see if in the triangle this is opposite and this is adjacent. So tangent will be equal to A over B, my dear students. This is the way how to pick the value of sides and write in the form of fractions. They are called ratios, and these are the values here. Sine trigonometric ratio is equal to A over C, that's opposite over hypotenuse, and cosine trigonometric ratio, cosine of A is equal to adjacent over hypotenuse, and tangent of A, third trigonometric ratio, that is equal to opposite over adjacent. Now, if I consider the second angle B here, my dear students, for example, that we are supposed to write the trigonometric ratios according to the angle B, then what will be the situation? Look at here. This is sine of B. Now we want to write the ratio of sides according to this angle B. So it means, now keep in your mind, hypotenuse will be the remain same because this is the opposite of the angle 90. But the rest of two sides now flipped. Now you can see here, this angle has opposite side here. Now according to angle B, now the opposite is B, then A will become adjacent. And now we will write the ratio of the trigonometric ratios when the angle B is considered and in use. So sine of B is equal to opposite over hypotenuse. Now the opposite is B and here is hypotenuse. So we will have value of B over C. Then we will see what happened cosine. Now because the sides flipped, this cosine is equal to adjacent over hypotenuse. And here adjacent is now A according to this angle. This is adjacent and this is hypotenuse. So we will write A over C, adjacent over hypotenuse, and the last third one, this is tangent here. This is equal to, we know it's equal to opposite over adjacent. And now as the sides changed, now this is opposite according to angle B, opposite. This is adjacent. This will be equal to B over A. So my dear student, you can see here, the first we learn how to write the labeling values of the sides of right angle triangle in front of trigonometric ratio. Sine equal to the value of sides, opposite hypotenuse, cosine trigonometric ratio according to the given situation when angle A is considered, and then tangent. And now in the same question, if the angle place is changed, now if we consider angle B, you can see here we got the different situation. The adjacent become opposite and opposite become adjacent, and then we have written these ratios, sine of B, cosine of B, and tangent of B when the angle B is under focus or considered. Now they have different fractions as compared to this one. So we need to focus, my dear student, whenever we got right angle triangle, we need to keep in mind which angle is actually used in trigonometric ratio, and according to that angle we will consider these two legs of right angle triangle, which side will be opposite and which side will behave like adjacent, and then we will write all these ratios, and in further steps obviously we will use them to find sides as well as angles as well. Alright, my dear students, if you look at this triangle, suppose instead of alphabets A, B and C, we have digits, numbers are labeled along these sides. If you look at here, suppose we have the same triangle with the same situation, that the angle, right angle is at C, and now sides are labeled with the digits. How we write the trigonometric ratio? It's the same sense. I just replacing the English alphabets ABC by the digit 3, 4, 5. Now in this situation, for example, I just want to consider angle A here and want to write the trigonometric ratio when the angle A is under considered. Let's see, here are the trigonometric ratios, my dear students. Sine will be equal to, this is opposite, and here in this angle opposite is 3. We will write 3 over, the hypotenuse is 5 here, 5, and then cosine of A, this should be sine of A Yes, it must be sine of A here. Alright, my dear student, if in triangle ABC, instead of alphabets ABC, there are the numbers like I have mentioned here, another triangle, which is actually the same triangle, but what I did, I replaced the English alphabet A by 3, B by 4, and this is by C. It's not a situation question that I have substituted the values, but I'm just considering to elaborate in these trigonometric ratio when the digits are given. It's the same situation, same triangle with the same right angle. Just to see how we will write the values in front of trigonometric ratios. I have considered angle A. Let's write trigonometric ratios here. This is sine of A will be equal to opposite. Its opposite is 3. So this is 3 over, here is hypotenuse is 5. Similarly, cosine of A will be equal to, this is equal to adjacent over hypotenuse. Now we are writing in the form of numbers, digits. That's actually we are supposed to deal with when we will using trigonometric ratios. This is 4 over 5 adjacent over hypotenuse. And now the last one is, this is tangent, that is equal to, this is tangent of A equals, that is opposite over adjacent. Here is opposite and here is adjacent, my dear student. Opposite is 3 and adjacent is 4. So whatever dimension along the sides, we need to focus on their actually behavior or actually their position. If they are in front of angle like this in opposite, so we will consider it opposite. The third value will be adjacent. According to their side, respective side, we will use them in trigonometric ratios. They might be English alphabets, that might be digits, my dear students. Alright, I hope now you will understand what we will do with the trigonometric ratios while using the sides given on right angle triangle. And now next we will see what is the use of trigonometric ratios in right angle triangle. It's mean how we will deal with sides and angles of a right angle triangle whenever we are asked to find some values in the triangle. Let's see in the coming up example where we will learn how to use trigonometric ratios. Keep on practicing, my dear students. Just first learn, then get practice. I assure you, you'll have very good concept. Let's see the next example where we will use. Alright, my dear students, look at example. This is example number 1. This is example number 2. Alright, my dear students, let's have example number 2 where we are going to learn what are the ways to use trigonometric ratios in right angle triangle while finding different angles and sides. But in the beginning, we will learn how to find different sides of a right angle triangle. Here, this is example number 2. It's a right angle triangle ABC with the right angle at C is given. If you look at the triangle, you see one side is labeled as X. It's mean in this statement, it is given that in this triangle, find, this is statement, find unknowns, find unknown in this triangle. Here X is unknown. You can see this side is given 12 centimeter. If you look at this triangle, the 90-degree angle, the side opposite to 90-degree angle is the longest one, that is called hypotenuse. This value is given 12 centimeter, and this side, according to the angle, that is 72 given. According to this angle, this X is on opposite side. This is opposite in this given question. So first of all, whenever you will have question, we need to diagnose and analyze what sides are given. Number 1, here according to this angle 72, we have given opposite and hypotenuse. Then we will think which trigonometric ratios is actually equal to this relation of opposite and hypotenuse. If you think that is sine, so sine of trigonometric ratio will help us to find this value. Here is the solution for this example. My dear, we will write the fraction containing unknown value first. This is x over opposite over hypotenuse. This will be 12. That will be equal to sine of angle that's used here in A, and its value is 72 here. We will write directly. Now we're dealing according to this angle given 72. So x over 12 opposite over hypotenuse equal to sine of 72, and the next one is the simplification where you will use something calculator as well. So x will be equal to, let's cross multiply. This 12 should be cross multiplied to other side because this is dividing here, and when it will be transferred, its operation will be reciprocal and that will be multiplied. This is 12 times, let's have the value of sine 72. You will get this value from calculator, and this is 0.951. I have calculated already. Yes, in trigonometry, whenever there are values of angles and calculations are going on, you will use calculator, my dear students. So sine of 72 is equal to 0.951, and the next step we will multiply them and we will get answer. Your answer is 11 point. Again, you will get this value from calculator. Get calculator, multiply them, and you will get this answer. Well, you can do this manually as well by utilizing the table of 12. 12 times 1, and then 12 times 5, then 12 times 9. Yes, you can manual process do here to get your answer. Here the value of x, the side opposite in this triangle is 11.4 centimeter, my dear students. Now, look at another example. This is example here number 3. This is example number 3, where we have given triangle. In a triangle XYZ, we have given right angle. Well, this is a angle Z is actually here equal to 90 degree. As I told you, when we have question to find unknowns and also find unknown here, find unknown in this example. So first of all, we are supposed to understand what sides are given of this right angle triangle. According to this angle, this is the opposite, this is the longest side, hypotenuse, and this side is adjacent. Only 3 sides are there, and here we have question that we are supposed to find the value of adjacent, that is mentioned here x. We will get help from hypotenuse. We will think what actually trigonometric ratio is that help us, that actually relating adjacent and hypotenuse, that we will write here. Here is the solution for this example. So adjacent over, yes, we need to analyze what is the relation of the given 2 sides in trigonometric ratio form. Here is adjacent and here is hypotenuse, and we will write here. So we will write this fraction adjacent over hypotenuse, that is 13, will be equal to cosine function here, and the angle given 37, my dear students. Or in the same way, here is this number dividing, we cross multiply it to other side, and we will get x is equal to 13 times 0.7, 9, and 8. This is the value of cosine of 37. With the help of calculator, you will write it, and then finally you will get the value of x. Multiply these 2 numbers, and you will get 10.4 centimeter, my dear students. Although it's the same process, what happened in this question, opposite were unknown. So we used sine trigonometric ratio with the help of opposite and hypotenuse. In this example, adjacent was marked as an unknown, we need to find this one. So we consider the fraction x over 13 and write equal to cosine of angle and proceed in the same simplification way. Now we will consider one more example to elaborate one more side of this right angle triangle. Alright, my dear students, that's our example number 3. Here you can see we have given hypotenuse that is in the form unknown, and the value of one side is 5 centimeter. Well, again, solving this right angle triangle means finding the value of this unknown here. Again, we will start thinking what sides are given according to the given angle. Then we will analyze which trigonometric ratio will help us. Here you can see adjacent is given, hypotenuse is there also there, that's what we are supposed to find. So adjacent hypotenuse, what trigonometric ratio relates with this one? That's cosine of angle. This is solution for this example, my dear. So 5 adjacent over hypotenuse will be equal to cosine of the angle given, that is 40. Now here, this is the third sense. I'm one by one covering all 3 sides. Now our focus is to find hypotenuse. We will cross multiply from here y to this side, so we can find this value of y, and this will cross multiply to this side. Like we can write 5 over, this is cosine of 40, and that is equal to y. What I did, I transferred this y to right side, dividing here, it will be in the form of multiplication when moved to the right, and this number I transferred to this side. It's in the state of multiplication, you can say, but we transfer to other side. Now here is dividing 5. Our focus, actually I made a subject y to get the value of y here. Now this fraction we will calculate and it will help us to find the value of y. Now 5 over, first of all, cosine of 40 degree equal to, my dear, as I told you, we'll use calculator, and this value is equal to 0.766, and this is equal to y, and implies that value of y will be dividing 5 by this number. 5 by this number 0.766 will give us 6.53 centimeter with the help of calculator. On calculator, divide 5 by this number, we will get this answer. Alright, my dear, in first 3 examples, we learned that how to find unknown marked in right angle triangle when one side is given. In all 3 examples, you see that there was only one unknown mentioned and the rest of information was missing. One unknown, one given value was there with angle, and we try to learn how to find its value. And coming up questions, you will see there's more use of trigonometric ratios and in more expanded way. Let's see for next coming up examples. Little harder, but it will expand our concept of using trigonometric ratios. Alright, my dear, we have example number 4, and here you can see in right angle triangle, one side is given is 12 centimeter, but the rest of 2 are unknown. Instead of previous examples where we got only one unknown, now here we have 2 unknowns we are supposed to find with the help of given information. Angle 62 is marked here, given 12 value, hypotenuse is given. According to this angle, opposite is need to be found, and here B is unknown that we are supposed to find. So again, my dear students, we will analyze which side we are going to deal. According to this angle, this is opposite. If we want to find opposite first, तो opposite and hypotenuse, opposite और hypotenuse की मदद से जो ट्रिग्नोमेट्रिक रेशियो बनता है, हम वो लिख कर इसे सॉल्व करना शुरू करेंगे. Opposite A over this is 12 is equal to, it is sine trigonometric ratio, sine of 62 degree angle given. Process is same, that this will be, we will cross multiply 12 here again. This 12 will be multiplied with the value of 62 with the help of calculator. We will write it 0.883 is the value here of sine of 60, and then when you multiply it, we get 10.6 centimeter, my dear. It's a similar process that we did before. Yes, Write the value of trigonometric function, multiply it, you will get the value of unknown. Now, for the second unknown, we will write this is adjacent. Adjacent and hypotenuse. You know, it's cosine. So b over 12, that is equal to cosine of angle 62. Again, we will cross multiply this value, and b will be equal to 12 into, let's write the value of cosine of 62, that is 0.6, it's a 0.46 and 9. This is value of cosine of 62. Now multiply these two, we will get the answer 5.63, my dear student, centimeter. Now this, you see, individually both we have done previously, only one time in a triangle. Now we got two unknowns and we are performing here for two unknowns in one example. Bismillahirrahmanirrahim. My dear students, let's have example number 5. Here we have given a composite figure consists of different right angle triangles. For each part that we are supposed to find, we are supposed to analyze in which right angle triangle our required side is here. Well, in some angles, angle 45, angle 60 degree is given, side 45 centimeter is QS side. And the first thing that we are supposed to find is, that is QT. Let's see in which right angle triangle this QT is present. Here is QT, my dear student. This QT is a part of this right angle triangle as well as this right angle triangle. But we need to consider right angle triangle whose sufficient values are there that help us to find QT. So that is triangle QTS. Let's start solving and finding this value. So we will move solution like this. In triangle, we are considering triangle. This is QTS. Now we want to work in this triangle to find the value of QT. So look at this. According to this given angle, this side that we are going to find is opposite. This is hypotenuse, my dear students. And we will write the ratio of these two sides, and opposite and hypotenuse combining make sine trigonometric ratio. So here is QT over, this is 25, is equal to, this is sine of 60 degree. Let's carry on this calculation for QT. QT will be equal to, this is 25 into sine of 60. My dear student, you will get the value of sine 60 from calculator. This is 0.866. And now for the finally the value of QT, multiply this value with 25 and you will get your answer. That is 10.4 centimeter from the calculator, or simply manually you can calculate as well, but it's better to use calculator if you have. So QT is equal to 10.4 centimeter. Now look at the second part. This is PT we want to find, and here in this picture PT is here. This is PT and that is in the triangle PTQ. But we see that we have only this side that we have found in part 1. 10.4 is the measurement here, and this side we're gonna find. We don't have other things. It means we are supposed to get help from the given values about the angles, then we can carry on our process. This is 60 degree. Here is 90 in this triangle. This QTS. It means that this angle would be 30 degree. Because in the right angle triangle, one angle is 90, तो बाकी दो का sum भी 90 के बराबर होता है. The rest of also has the sum 90. If this is 60, it must be 30. Alright. Then with the help of this straight line, it's a straight line, and the whole straight angle here equal to 180. We know this is 90, this is 30. This becomes 120. Now if we subtract 120 from this straight angle 180, we will get 60 degree angle here. This is 60 degree, my dear students. Now we have enough information in this triangle PTQ where we can find PT. So here this is part number 2. In triangle PTQ we are going to find PT here. This is PT over PT. According to this angle, this is opposite and this is adjacent. We have given value. This is 10.4. So opposite over adjacent is relation that give us trigonometric ratio tangent. This is equal to tangent of 60 degree. So therefore PT will be equal to, this is 10.4 times, we will get the value of tangent of 60, that is 1.73 from calculator, and I will multiply them, so we will get 18 centimeter value of PT. So my dear, after this calculation simplification, from I cross multiply this number to here, I got PT is equal to 10.4 into 1.73, and I multiplied with the help of calculator, I got 18 centimeter is the length of PT. Now for the third part, this length PR is the composition of two parts PQ and QR. We will find PQ from the triangle PTQ and we will find QR from the triangle QSR. Let's work for PQ first. Solution for PR. This is equal to PQ plus QR. So to find PR, as I said, we need to find individually PQ and QR. Let's work for PQ. This is PT, whose value we have found, that was 18. PT over PQ, that our focus here, is equal to sine of 60 degree. Opposite over hypotenuse, our focus is to find this hypotenuse is sine of 60. So therefore PT will be equal to, this is PQ, I have cross multiplied, and this value I cross multiplied here as a denominator, its value that is equal to 0.866, 0.866, and therefore implies that PT we have 18, this is 18 over 0.866 will be equal to PQ here. And now with the help of calculator we can write the value of PQ. We will divide 18 by this number and we will get a value of PQ. So we got 20.8 centimeter, the value of PQ from this triangle we got, and now we'll find the value of QR from this triangle. Let's see, in this triangle QR, if we look at this angle, yes, this side is the opposite of this one. This is opposite, this is adjacent. This is hypotenuse. We are given opposite and adjacent. We will write this value QR that we want to find here divided by 25. This is behaving as adjacent. This is equal to tangent of 45. Therefore, QR will be equal to 25. It's a 25 into value of the tangent 45. We know tangent where 45 is 1. You can check the calculator. Its value is 1. So therefore, we got QR equal to 1. Actually, we wanted to find the value of PR. These are two components we have found separately, and now we will combine them. Therefore, the PR length is equal to value of PQ and QR. PQ here is 20.8. This is 20.8 plus here is 25. Let's add them. We will get 45.8. When you add these two, the answer would be 45.8 centimeter is the length of this PR part number 3, my dear student. Now I hope you could understand that when you have composite picture, it consists of different right angle triangle. What is the way of handling the part on you're focusing on? You need to just analyze in which triangle this part is. Now mention, there is no need to mention that triangle. It's better if you mention, you keep yourself in that triangle for finding that value QT, and then PT in this triangle, and then for PR we see two parts we need to find and in separate triangles that I did here. कि पहले मैंने PR में से PR की वैल्यू के लिए PQ फाइंड किया, अलग वैल्यू फाइंड की उसकी, PR की वैल्यू फाइंड करने के लिए पहला हिस्सा PQ फाइंड किया, here is PQ, ये वैल्यू आ गया मेरे पास, एंड देन उस दूसरा हिस्सा QR फाइंड किया, ये कैलकुलेशन करके ये वैल्यू आ गई 25. PR के लिए PQ एंड QR की वैल्यू निकालकर उन दोनों को सम कर लिया. सो PR इज इक्वल टू सम ऑफ बोथ PQ एंड QR. दैट अल्टीमेटली हमारे पास वैल्यू आ गई 45.8. दैट्स अल्टीमेटली वी हैव PR दैट्स 45.8. That is the way to handle this kind of questions. Let's see little more expanded questions, more difficulty level questions related to the use of trigonometric ratios, my dear students. In coming up example, we'll see some more questions. Get practice. Keep connect yourself with this system of math.mathpk. You will get excellent preparation, my dear. I assure you, if you follow the guidance, you will prepare your mathematics and these topics like trigonometry in an excellent way to make you math very easy and interesting for you.
डियर स्टूडेंट, सब्सक्राइब बटन और बेल बटन को दबाएं ताकि मेरे वीडियोस आपको सबसे पहले मिल सकें.